Hey guys, he made me do that. Anyways, today we're going to be, he's going to be instructing you on Unit 13.1 and 13.2 quiz review, narrated by Coach Moore, of course, and I'm the special guest, John A. Hi!
Hey, what's up, y'all, man? Hey, I am Coach Moore, and that was Janae's awkward introduction. All right. Hey, we are going to hit this 13.1, 13.2 quiz review, guys. Hey, I hope this helps you study and prepare, man. We're on the home stretch of the semester, coasting through, guys. Please take advantage, man, of the opportunities to get that GPA where you need it to be. Let's not be super seniors or super juniors, okay? Let's take advantage of our resources in life. With that being said, let's go ahead and dig in, man. Here's f of x, g of x, and h of x for each function. We're going to find the forgiven. We have f plus g of x. Guys, this does not mean f plus g times x. All right, this means evaluate the functions f plus g, add those two functions with respect to x. All right, that's all that means. It basically means when I do it, I'm not going to have some numerical solution. No, I'm going to have equations or expressions remaining, and they will have the variable x in them, okay? So, f for x squared minus 9, and we're going to add c plus g, 6x squared plus 7x minus 3. Now, when I add those up, guys, since we're adding, we add like terms. So I'm going to look at the squares first, 4 and 6. That's going to be 10x squared. Remember, you only add the constants, all right? Or excuse me, you add the coefficients. You do not add the variables and their exponents, all right? Now we have 7x. That's the only single x term. All right, or x with a degree of 1, so we're going to keep that, 7x. And then we have negative 9 plus negative 3, all right, or negative 9 minus 3, and that's going to be negative 12. All right, here is your final answer for this one, 10x squared plus 7x minus 12. All right, moving along here, we have f minus g of x. All right, so how do we solve this one? We take f, 4x squared. Oh, hold on. We're on the fritz. 4x squared. Man, why does that not want to write? Okay, one more time, guys. 4x squared. There we go. 4x squared minus 9 minus, all right, since I'm doing subtraction here this time, guys, let's go ahead and put this in parentheses. Plus 7x minus 3, okay? Now, what you got to do is we're going to have to distribute that negative there, guys. That's why I put the parentheses around it, the negative. So you have 4x squared, and this thing, I need an upgrade. So 4x squared minus 9 minus 6x squared minus 7x there we go, plus 3. All right, so now that we distribute the negative, we'll simplify. We have 4 minus 6. That's going to give us a negative 2x squared. Then we have negative 7x. And finally, negative 9 plus 3 is going to give us a negative 6. Okay, so there's our final answer right there. Next, we have, I'm going to erase this, guys, so we'll have some space to work on this next problem. Here we have f times h. So f again is 4x squared minus 9. And since we're multiplying on the parenthesis everything, h is 3x minus 1. So, of course, man, when you're multiplying polynomials, these two binomials are going to FOIL. So, we're going to go 4x squared times 3x. Well, you do the coefficients. 4 times 3 is 12. And then x squared and x gives me x cubed. Then I'm going to do 4x squared times negative 1. That is negative 4x squared. Then we have negative 9 times 3x. That is negative 27x. And finally, negative 9 times negative 1 is positive 9. Okay? There's our final answer right there. 12x cubed minus 4x squared minus 27x plus 9. Again, I'm going to erase so I can have space for number 4. Number 4, we have f, 4x squared minus 9, divided by g, 6x squared plus 7x minus 3. These, since it's a division problem, guys, you need to factor them. All right, you need to factor both of them. The top one's constant is a difference of 2 squares. All right, difference of 2 squares. We can factor that. 2x times 2x gives me 4x squared, and then negative 3 and positive 3 gives me 9, negative 9. Down on the bottom, though, it's a little different. Down at the bottom, I'm going to use factor by grouping. All right, just a quick tutorial, man. I'm not going too in depth with it. I'm just going to work it out and show you. This leading coefficient and that constant, if I multiply those, I get negative 18. The factors of negative 18 are 9 and 2, and negative 9, and, well, 9 and negative 2 have negative 18, and negative 9 and positive 2. 9 minus 2 gives me 7, so that's how I'm going to group it. I'm going to go 6x squared. Actually, let me use another color for this because it's not the answer. 6x squared plus 9, 9x, sorry. Plus 9x. Alright, and then over here we're going to have negative 2x. Man, bear with me, guys. Alright, here we go, back at it. So negative 2x minus 3. Now notice this negative 9. I'm sorry, that should be plus 9. Alright, this positive 9. See, 9 minus 2 is 7, so 9x minus 2x is 7x. Alright, so that's where I got that from. Anyway, when I factor this side, I take out a 3x, and I'm left with 2x plus 3. And over here, I'm going to factor out a negative 1. So I'm left with 2x plus 3. And then that's my factors, guys, right there. 2x plus 3. If I factor that out, I'll have 2x plus 3. And I'll have 3x minus 1. Okay. So there are my factors for the bottom G. So now, what can I cancel, guys? I can cancel this out right here. 2x plus 3 and 2x plus 3. So I'm left with 2x minus 3 divided by 3x minus 1. Okay? But there's one more thing. You got to tell me where it's undefined. Alright, so we have 2x minus 3 and 3x minus 1. And it's undefined where x cannot equal 1/3. And the reason it's 1/3 is because, again, if you take this denominator, if you saw my other videos, if you take this denominator right here, 3x minus 1, I'm doing another color so you can see it real quick. if I took 3x minus 1, the denominator, and set it not equal to 0 and solved it, I would add 1 on both sides. And you'll have 3x is not equal to 1. And so once you're here and you divide by 3 on both sides, you get x is not equal to 1/3, which is why I have this restriction. So here's your final answer on number 4, guys. All right, took some work because I had to explain this to you. It's not really that long factoring. You just got to be able to factor, man. Reach in your bag of tricks and factor how you factor, okay? Now, that's number 4, man. Let's go and take a look at 5. Over here at 5, we've got to do g divided by h. Well, g again is the 6. Come on, write the 6. Oh, man. 6x squared plus 7x minus 3. And h is 3x. All right. So now, we go ahead and factor that top again. We just did it. Remember, it was 3x and 2x plus 3. And it's all over 3x minus 1. The 3x minus 1s are going to cancel right here, guys. So the only thing remaining, the only expression remaining is 2x plus 3. All right, there you go. 2x plus 3. All right, number 6. Evaluate f of g of 5. All right. Again, a couple different ways you can do this. I'm going to work these out a couple different ways so you can apply them however you've been instructed, okay? The first one we're going to do is see the internal function g of 5. All right, this is g of x, okay? But it says x is 5 right here. Y'all see that? 5 is in the parentheses. So I'm going to evaluate this x for 5. So that would be g of 5 equals 2 times 5, because that's g of x. And we're evaluating the x is 5. So 2 times 5 is 10. Okay. Now I got to evaluate the outside function, which is f. So I'm going to take that 10 and plug it into f. So f of 10. So if I go 2 times the square root of 10, 10 minus 1 is 9. And the square root of 9 is 3. And 2 times 3 is 6. So fg of 5 equals 6. All right? Equals 6. For this next one, evaluate g of f of 11. We've got to plug f this time into g. All right. So I'm going to evaluate the internal one first, f, for 11. So I have 2 times the square root of 11 minus 1. Well, 11 minus 1 is 10. And that's it, guys. All right. F of 11 is 2 square root of 10. This doesn't simplify. Okay. So now I'm going to plug that into g of 2 square root of 10. All right. And when you do that, you get 2 times 2 square root of 10. And you end up with 4 square root of 10. Final answer. Lastly, right here, I'm going to evaluate g of negative 5 first. When I do that, we're going to have 2 times negative 5. which is negative 10. So now I take the negative 10, I'm going to plug it into F. So you have 2 times the square root negative 10 minus 1. Well, that's 2 times the square root of negative 11. And then you can't simplify that negative 11, guys. That doesn't have a perfect square in it. But I can take that negative out. The square root of negative 1 is I. So to conclude this, we have 2I square root of 11. Final answer. Okay. Now, number 9 here, a composite function. We need to be inside of F. All right, cool, simple enough. We know that F is 2 times e of x minus 1. But I need to evaluate it for g. That means that g is going to go in place of x. G of x is going to go in place of x. 2x is going to go in place of that, so 2x. Now we simplify it, and we can't. This is it. 2 times the square root of 2x minus 1. And then let's just find a domain. Well, this is a radical, okay? So whenever you find the radical's domain, you have to remember that the smallest square root possible is 0. All right? That's the smallest square root that exists, okay? So what that means is I take what's underneath the radical and set it greater than or equal to 0. Like that, and solve it. I will add 1 and then divide by 2. So the domain here, guys, if you add 1 and divide by 2, you'll have 1, greater than or equal to half. X is greater than or equal to 1/2. All right. Greater than or equal to 1/2. Because even if you put 1/2 here, it'll work. It'll use 0 squared root of 0 is 0. All right. So that's your domain restriction. This next one, find g of f of x, meaning you have to put f inside of g, like so. All right, now simplify it. All you can do is multiply by 2, so you have 4 square root of x minus 1. Now we got to find a domain restriction. Again, it's a radical. The smallest square root possible is 0. All right, so again, I'm going to take what's underneath the radical, set it greater than or equal to 0, add 1. So for the domain, I get x is greater than or equal to, man, that didn't work out, 1. That's your domain. All right. Okay. All right, so for this problem, Derek Boss is so impressed with his ability that he wants to give him a raise. Derek made $8 presently, and his boss wants to give him a 20% raise or a $2 an hour raise, okay? So, which is better for Derek and why? So let's go ahead and review the 20% raise. If you're already making $8 an hour and we want to increase that by 0.2%, right? We will do 8 times 0.2 or 0.20 since it's 20. I'm going to give you 1.6. So that's basically saying $8 plus $1.60 more, which will bring you to $9 an hour. Okay? Well, the latter is if you're making $8 add $2 an hour raise, that brings you to $10. So obviously, the $10 an hour, we take the $2 more. So we would definitely take the $2 raise because we're making more an hour versus the 20% raise, okay? So now B, it says, then he decides to give Derek both raises. That's a great boss. But Derek must decide which order to apply them. All right, so which order will give Derek the highest hourly rate? And how much will he get? Well, think about it, right? Let's say we did the 20% first. If you do the 20% first, you now make $9.60 an hour. And then if you add the $2 to it, that will give you $11.60 an hour, right? Now, let's say we did it this way. Let's say this way he got the $2 an hour first. So now you're making $10 an hour. All right, but now you're going to apply a 20% increase to that, which is $2 more. 20% of 10, guys, is $2 more. Gosh, that won't write correctly. I swear I need a new slate, y'all. All right, there we go. It's $2 more. So if I was making 10 and I add 20% of that, I'm now making $12 an hour. So again, which way do you want to apply it? Do you want to go 20%, then add $2 to it to make $11.60 an hour? Or do you want to add $2 to it and then go 20% to make $12 an hour? I think we will definitely take the $12 an hour. So the way to apply it is to add the $2 an hour raise, then add the 20% raise, okay? And we'll be at $12 an hour, okay? Now, this problem here. It says, given questions 12 and 13, given the tables shown for f of x and g of x, find the following. G of f of 1. So first we need to find the internal function f of 1. Well, this is f of x. Here's f of 1. So f of 1 means x is 1. So where x is 1, because this is your f of x table. Let me clear that up. This is f of x. This is g of x. Okay? I can actually make this smaller because I don't need to write so big. All right? So x is 1 for f of 1. So where x is 1, f of x is 4. So now we got to find g of 4. Well, that means x for the g is 4. So that means g of x would be 3. Over here, g of 4, x is 4. So for g of 4, you have 3. Right? So now I have to find f of 3. So for f of 3, you get 2. Here's our final answer for number 13. All right, over here, g of f of 1 equals 3. Over here, f of g of 4 equals 2. All right, go ahead and turn over. Let's look at our back. Questions 14 to 15 from the graphs below. Determine if the relations shown is a function and if the inverse is a function. All right, to show if it's a function, I use the vertical line test. All right, there's the vertical line test. This is a function. All right, so it is a function. That's the first part. All right, determine if it is a function. The second part is if the inverse is a function, okay? Now we want to check and see if it is, if the inverse is a function, okay? And see the horizontal line test? All right, for the inverse, you do the horizontal line test. See how this line, or even this line, touches that relation twice? All right, that means its inverse is not a function. So here's what you got to have. So we can conclude that the vertical line test proves that it is a function. All right, again, the vertical line test, because the vertical lines touch the function one time. See, that's one time. That's one time. It only touched that relation one time. But those, if I go back to the horizontal line test, that touches twice. So the inverse proves that. Oh, you know what? I need to add that in there. Let's do that. Proves the inverse or proves its inverse is not a function. Okay, so its inverse is not a function, guys. All right. Now let's go over here. For this next problem, if we do the vertical line test, all right, see how this vertical line touches at 2 points? All right, because it touches at 2 points, we just show that this relation, sorry about that, guys, this relation is not a function. All right, and if we do the horizontal line test, see how that touches twice? You can do it anywhere. Touches twice, see it? All right. But since that is the case, then we can conclude, I want to type now. There we go. We can conclude the inverse of this function, of this relation, is not a function. All right, so there we go. This relation is not a function, and the inverse of this relation is not a function, because the vertical line and the horizontal line test shows us that they both touch twice, and therefore they're not relations. Okay. Now 16. Let's see here. Find the inverses of the following functions. All right. Who remembers? I hope you remember the steps. If you don't, I'm going to add them. Hold on one second. All right. To find the inverses. Remember now, to find the inverses of any function, here's the steps. Switch x and y, then solve for y. So that's what we're going to do here. All right, we're going to switch x and y. Hopefully you guys remember that f of x is the same thing as y. So y equals x cubed plus 5, right? Well, I'm going to swap x and y. Okay, so I'm going to have x equals y cubed plus 5. Plus 5. There we go. So my first step here is to subtract 5 on both sides. So x minus 5 equals y cubed. And we need to remove this cube right here, this cube. And how we're going to do that is we're going to take the cube root on both sides, like this. So on the left here, we have the cube root of x minus 5. And on the right here, the cube root and the cube cancel each other out. So the only thing that remains is y. All right, y. So this is the inverse right here, guys. For this next problem, we have, remember this is y, right? So we're going to end up with x equals 4y minus 7 all over 6. Now, to solve this, the first thing we're going to do is multiply by 6 on both sides. The reason I do that is to cancel out that 6. So you now have 6x equals 4y minus 7. And then from here, we can add 7 on both sides. So I have 6x plus 7. Wait a minute, that didn't take right. Equals 4y, right? And now there's one more step. We're going to divide each side by 4 to isolate the y, okay, to solve for y. The 4 is over here on the right cancel, and I'm left with 6x plus 7 divided by 4 equals y. Alright, so that is the inverse for number 17. Alright guys, so now we are at the point to where we need to, let's see here, do number 18. So let me clear this off, guys, so I can have some space. Now, number 18. Number 18, let's find the inverse. Again, this is y, guys. So we're going to swap x and y. So we have x equals the square root of 2y minus 3. Now, I think the obvious thing here is to get rid of the radical first. Since this is a square root, we're going to square both sides. So I have x squared equals 2y minus 3 because, guys, see the square root and the square? Those negate each other. They cancel out, okay? Now, we're going to add 3 on both sides. So we have x squared plus 3 equals 2y. And then we're going to divide by 2. So y equals x squared plus 3 divided by 2. There's your inverse, guys, okay? Alrighty. Now, last two problems. Man. Determined by composition. Alright, now if you look back on the front, you did composition functions. You did it right here. You did 6, 7, 8, 9, and 10. Alright, these were composition functions, especially these two. And that's exactly what we're going to do on this back side. Alright, with these composition functions, the first one we're going to do is f of g of x. Alright, now the rule is when you determine if by composition, if the following are inverses, you want to solve to get just x. So when I do f of g of x, I want to solve it and see if I get x. If I do get x, guys, then they're inverses. If it's anything else other than x, they're not inverses, okay? We want to get x, okay? Even if I do g of f of x, I should get x. And if the answer is x, they're inverses, okay? So let's go ahead and do this first one. F of g of x, meaning I'm going to put this function in place of this one. So I go 6 times this now is no longer x, is now this, x plus 2 divided by 6, minus 2, right? That's minus 2. Here's what happens. So I'm left with x plus 2 minus 2. All right. So now we have positive 2 minus 2. That's 0. So I'm left with x. Okay. Now, do it the other way. G of f of x. I'm going to take this time this function will be plugged into that, okay? So I go 6x minus 2 I don't know why it doesn't like writing 2's, guys. I don't know if you've noticed that. Every time I write a 2, this thing plus 2, because remember I put that right there, 6x minus 2 plus 2 all over 6, okay? So now, if you look right here, negative 2 plus 2 is 0. So I'm left with 6x divided by 6. All right, and the 6 is canceled, so I'm left with x. X remains. So we can safely say that these two are inverses. All right, they are inverses of each other. Both undid each other to have just a single x remaining, okay? All right, let me clear it off one more time. So we can do our last problem. Man, and again, man, if y'all missed something, if I went a little fast right there, just remind it and listen again, okay? For this one, I'm going to do f of g of x. Okay? So I'm going to put this one in place of that x. So, all right, so here's what we got, okay? So now, this right here, we have x squared plus 4 minus 4 outside. All right, and well, guys, this doesn't simplify. This is in the simplest form. So because it doesn't simplify, I can go ahead and tell you, man, that these are not inverses of each other. Remember the rules. If these were to simplify to get x, they are inverses. This doesn't simplify. Okay, so it is not an inverse. All right. Well, man, that's it. That's the video, guys. I'm approaching 37 minutes. So with that being said, good luck on your upcoming performance finals and final exams. Hopefully this video helps. Coach Moore out, guys. Oh, subscribe if you like the video. Give me a thumbs up, please.